Hello there. Good afternoon. This is Michael Kinnett from Internal Networks. This is our weekly iTNet Tech Update live stream. So we do this every Friday at 1 o'clock on our social media pages. So thank you for those of you that are watching this live. For those of you that are watching it after the fact, I appreciate you as well, your time to get this little tech update from us. So today, I'm going to be talking about encryption. Just like in past videos, we want to educate, we want to provide some tips, and then hopefully we provide some good information that can help you in your small business. So today, talking about encryption, I'm going to take a step back from it and kind of explain what it is before I go into how it can help you in different ways that you can use it in your business. So encryption, may sound super complicated and everything, and it can be, but it can also be pretty easy to understand, right? So encryption it's an important tool that enables you to send secure and confidential information online. It's also used to store files in a secure manner so that if those files are lost or stolen, they cannot be read, to protect the data that is contained inside of those files. Encryption basically works in a way to scramble the data, to scramble that text. And I put together a few slides here. Let me share this with you real quick. All right, there we go. So how does encryption work, right? So yes, it's a privacy tool. It's a way to secure documents and data in both at rest and in transit, so in between locations, right? And so this is a basic high-level understanding of what encryption does and how it works, right? So this example I have here, this is a basic text, right? So I have some basic text here I just wrote. This is the basic text that is being sent in an email. Once it's encrypted, it will be unrecognizable. I took that text and I then ran it through an encryption algorithm and got the middle text, right? Which is gibberish, right? Nobody looking at that can understand, oh, that means this is the basic text, etc. It's gibberish. That is basically what encryption does to files and to information data that's being sent. So how it does it is it takes that plain text and it applies an encryption key. And that encryption key then basically translates that text into the gibberish. And then you have a decryption key that reverses that. So if this was an email, I would say, hey, I'm going to encrypt this email. I send the email out as the basic text. On the back end, the system, the encryption system, the email security system then encrypts it and sends it in that encrypted gibberish format. And then on the recipient's end, once they receive it, their system then has the decryption key and it unencodes or unencrypts that data so that they can then read it. And it's legible for them. And there's lots of different ways that it does this. There's different type of algorithms used for encryption. There's different types of encryption. So one of the most common is AES, and that's the one that U.S. government uses and recommends, and many businesses use. That's the one that we use. And there's different types within AES. So you can have AES 128, which uses a 128-bit key to encrypt. There's 196, 256, 512, 1028, right? And the longer the encryption key is, the harder it is to decrypt that, unless you have the decryption key. So here's an example. If we were using the 256-bit AES key, there are 110. I'm probably going to butcher this. Quatuor, I've even practiced this. 110 quatuor vigintillion. There's 75 zeros after the 110. So that's how big of a number it is, right? So that's how many different variations there are, possible combinations for AES 256 keys. The fastest supercomputer in the world can only process 93 trillion processes per second, operations a second, right? Which is a lot. It would take that supercomputer, I don't even know how many years that is, 37,500, some massive number. There's a whole bunch of zeros there, right? That's how many years it would take that supercomputer to cycle through all the different variations of that encryption key. So it's pretty secure. there's not a whole lot of need based on today's technology of encrypting at a higher bit rate than 256. All right, so that key, that public key, or that encryption key, there's two types. There's the encryption key and there's the decryption key. And what they're called, the public key is one side and the private key is the other side. So the public key frequently is sent with the file, right? So it's public. It's anybody that intercepts that file, that has that file, has that public key. And that was what was used to encrypt it. But it needs a related key to unencrypt it, which is the private key. So this is a sample public key, right? So this is the code that was used to encrypt a file, right? So this is the key it's sent over. And unless that recipient has that private key that's unique to them, right, they're not going to be able to view that data. It's just going to show up as gibberish. Now, I've been using email as an example, but there are other ways that encryption can be used. One of those is to encrypt your computer. If you are in healthcare and you have HIPAA requirements to protect patient data, one of the best ways of doing that is through encryption. And so if you have laptops and portable devices, adding a layer of encryption to those hard drives enables it that if that device is lost, stolen, whatever happens to it, that data is protected because they don't have these keys, right? So these are the two most common, right? You've got Bitlocker for Windows. So if you have a Windows computer, you can enable Bitlocker. And what it does is when that computer turns on, it comes up and says, hey, what's the password? What's the encryption key to then unencrypt this hard drive so that we can boot to Windows and you can access the data. For Apple, it's called File Vault. It works very similar, right? You turn it on, it comes up and says, what's the disk password? That disk password is that key to unencrypt, right? So you create your own passphrase or password key that can unencrypt that data so that it can boot and then you can access it. So I kind of went through, hopefully that wasn't too technical for you, but that's basically how encryption works and where it's used. Now, some of the reasons that it's important to use it is one, obviously security to protect your data, and privacy to make sure other people are not intercepting and reading information that is important. But it also helps to maintain the integrity of the file, right? So nobody's going to manipulate the data or change the data as well. And a lot of businesses have regulations. I mentioned HIPAA, right? So if you meet HIPAA requirements and PCI requirements, Sarbanes-Oxley, there's a whole bunch of different requirements and regulations out there depending on your industry. And some of those may require various levels of encryption within your organization. So it's important to know what regulations there are and that you need to apply in your business. I would recommend before you enable encryption on anything, make sure you have a solid backup. Because if you encrypt something and you do it wrong, and you lose access to that data because maybe you had caps lock on when you're typing the password to use to encrypt it, and you can't figure out that you had caps lock on when you're trying to unencrypt it, you may lose access to that data. So start with a backup. Make sure you have a good backup first. And Apple and Windows make it fairly simple. You can open File Vault on Apple, you can open Bitlocker on Windows, and walk through the wizard and what it takes to encrypt that system. Another recommendation I would make is if you can use a tool. So we're a big Sophos partner. You've heard me talk about Sophos before for various different security things, and Sophos has a Sophos encryption piece, Sophos Central Encryption, and where you can manage those things. So if a user forgets their encryption passkey, there are ways of resetting it that are built into Windows and built into Apple. And it has to be tied to a trusted third-party system, right, to be able to do this. But you're able to go in and use a one-time code to unencrypt that system to get back into it. So I do recommend looking at a system like that, like Sophos Central Encryption. If you have questions on that, please reach out to me. We can definitely set up. It's fairly inexpensive, I think a couple dollars a month per system that you're encrypting, and it can make it very easy to manage. To one, make sure that encryption is turned on and those policies are applied, but then also recover, in the event maybe you have an employee leaves and they're the only one that need that encryption key, right? Where you can go in and reset it and change that key. So that's my recommendations with encryption. If you have any questions about encryption, I'd love to answer those questions. If we need to do a deeper dive, or if maybe something was confusing, please post them in the comments below, or shoot me an email. You can always, reach me through my website, eternalnetworks.com, or the shortened version, iTNet.works. We are having a webinar coming up. It's actually going to be on May 12th. We're going to be talking about why your business needs a cybersecurity risk assessment. We're going to be talking about, first, why you need it, what it should cover, and then what our processes are when we perform cybersecurity risk assessments. So it should be very informative, help you to understand the need for that in your business. So it's going to be May 12th, Thursday, May 12th at 1 o'clock. Hopefully we'll see you there. And if not, we'll catch you on our next iTNet Tech Update every Friday at 1 p.m. Hope you have a wonderful day.